Hello, everyone, and welcome to a new session for Computer Science 2, Spring Semester 2023. Today, according to the syllabus, we are on week 1, and we have to go over chapters 6 through 12 as a quick review so that we are ready to start with more advanced topics from the book. Let me hide floating meeting controls. Here I have just a base code for a simple program. It's just the main function. Let me go ahead and draw our roadmap for each chapters for the topics that we need to review. So for chapter 6, we have to go over defining functions, calling functions, function prototypes. This way we don't forget anything. We need to know how to send data to functions. We need to know pass by value versus pass by reference. We also need to know the return statement. We also need to know return types, the different types that we can return. We need to know local versus global variables. We need to know static variables. We need to know default arguments. And finally, we need to know overloading functions or function overloading. So this is what we need to go over. Let's go ahead and switch to Visual Studio. So the first topic is defining and calling functions. Quick review, why do we need functions? We need functions so that we break down our program into smaller, manageable pieces. The smaller the pieces are, the better management and control we have on our code. This way, if a code is broken, if there is a bug in one of the pieces, it's easier to debug the small piece or to replace the small piece than to change the entire program. Also for reusability, if we have smaller pieces, this way we can have the same code being called more than once instead of duplicating that code. So what is a function? A function is a group or collection of statements that perform a specific task. So if you have that task that needs to be performed more than once, instead of writing those collection of statements more than once, you just write them in one function, and then every time you need to perform that task, you just call that function in a smaller, more better way instead of rewriting the entire collection of statements. The format for any function is basically return type, this would be a function header. So the function header is the return type. Then you have the function name. Then you have parameters list. This can be called parameters list, can be called arguments list, or can be called the input list. So this here goes inside the function, and this here gets out from the function. So any function will receive some input and return some output. Some functions do not receive anything. Some functions do not return anything. Some functions do not receive and do not return anything. And we're gonna see examples. So this here is function header. Then you have the scope of the function. The scope is represented by a curly braces. So anything between these two scopes is the function body or definition. So everything here inside this scope is the body for that function. It's the collection of those statements. So let's give an example for defining a method that doesn't return anything and doesn't receive anything. It just displays hello world on the screen. So the fact that this function doesn't return anything, so the return type is a void. What would be, I'm following the header. This is the format of my header. So starting with the return type, what would be my function name? I'm gonna say display hello to the screen. What is my parameters list? It's empty, it doesn't receive anything. I open the scope, curly braces. What is my collection of statements? In this case, I only need to display hello world on the screen. So return type, display function name, and then parameters list. This is my function body. In this case, it only has one statement. So I defined my function. Now main, as you all know, main is the entry point of my program. So when I execute my program, this function will get executed first. So inside this function, I'm just gonna call my function. And the way I call my function is as such. I give the function name and open parentheses. In case this function requires input, I pass the input in here. In this case, this function doesn't require an input, so the parameters list is empty. So I'm gonna execute with the F10. So here is the entry point. I reached my function call. So now when I hit F10, this function has been called, this collection of statements has been executed, and I'm gonna see hello world on the screen. And done. For whoever doesn't know, you can step into your function. So using the F10, I started my program. Now at this line, I'm gonna click F11. Now when I click F11, I am inside the function. So F10, 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 now I'm back to the main function. So main called display hello, and now the control is back to main. So this is how you define functions. This is how you call functions. Let's show examples on functions that receive inputs, functions that return some output. For example, instead of displaying a hello world, I want this function to display any string that it receives. In this case, it receives a message, and then I'm gonna display the message. So notice now, IntelliSense and Visual Studio is telling me there's an error here, too few arguments in a function call. It's telling me this function is expecting a reply, is expecting an input, but I did not pass an input. So I'm gonna go ahead, create a local message, and I'm gonna say hello world. Now I'm gonna pass this message to my function. So if I execute with F10, I'm gonna see that my message is ready. I'm gonna pass it to display hello. Now I'm gonna see this message on the screen. It doesn't necessarily need to be hello world. I can pass anything. I can pass my name, for example, and I will execute. And the function will display that value. I can pass two I can pass two parameters and or more. So for example, I'm gonna pass a string, I'm gonna pass an integer for the count. Something like this. This keyboard is different. So integer, I'll count, I'm gonna say 10. So in this case, Visual Studio is gonna tell me, hey, too few arguments. This method is expecting to receive 2 arguments, but you are only sending 1. So I'm gonna go ahead and send the other one. So I will execute. And now the message will be displayed on the screen along with the second parameter. Now, how about if I want to return some value from my method? Let's say I need a method that receives 2 integers and returns the sum of them. So what is the type of the sum of any 2 integers? The sum of any 2 integers is of an integer type. So the return type would be integer. I'm gonna call it sum. Sum will expect first number and will expect second number. What would be the task for this method? The task for this method is to calculate the sum and return the sum. So how do I calculate the sum? I'm gonna say integer L result equals A first plus A second. Now that I calculated the sum, I'm gonna say return L result. This is my function body. Now I'm gonna call my function. I'm gonna create a local first equals to 10. I'm gonna create a local second equals to 20. And then I'm gonna say int L sum, it's a local variable. And then this sum would be equal to whatever the function sum returns. So L first, L second. This way, I'm telling my program, call the function sum. Here's the first input. Here's the second input. Now return the value. This statement will return a value, and then this value will be assigned to this variable. And finally, in main, I'm going to display L sum on the screen. Execute. Here it is 30. 10 plus 20 is 30. Function prototypes. This here is the function definition. It has a header and it has a body. Function prototypes are like a declaration of functions. The way you declare a variable, you can declare a function. Here I declared a variable and assigned value to it. Here I declared a value, but I did not assign a value to it. This is similar to a prototype in a function. So this here, I declared a function and I gave a body to it. I can declare the function semicolon. This here, declaring the function without giving it a body. I don't need to give a name for the variables. I don't need to give curly braces or a body for this function. This format is called function prototype. Usually, what you are gonna see, let's remove the unneeded things. You're gonna see function prototypes on top, and then main, and then you're gonna see function definitions at the bottom. Notice before I provide the function definition, notice this green error or green underline. It's gonna say function definition is not found. If I declare a function and I use this function without providing a body, I'm gonna have issues. My Visual Studio is gonna say, hey, something is not right. You're trying to use a function that doesn't have a value, doesn't have a body. So it's a good approach to have all your functions declared on top of main, and then you have main, and then having the function bodies below main. This helps in debugging and separation of concerns for your program. And this here is still working with one file only. Later, you're gonna learn that function prototypes go in one file, the execution goes in another file, and then the bodies go in a third file. And you can see those here. Header files are where the prototypes live, and source files are where the body lives. But for now, you don't have to worry about it. Excuse me. So with that being said, this is the function prototype, and this is the function bodies. This is just a review. So in case you think you don't know what this means and you really don't have solid understanding, and yet this is the first time that you see function prototypes, you have to go to the chapter and read the chapter. Anything in this session that is new to you, you have to go and read the chapter. So function prototypes done, sending data to functions done, pass by value versus pass by reference. Here, in this format, in this example, I'm passing two values to this function. This function will receive these two values and it will perform a task. Let's have a function called integer, or let's have it as void and call it increment. And this function takes only one integer. So I want this function to receive a variable and increment its value by 1. Now that I'm done with the sum, I'm going to remove my example. I will actually remove the entire function to keep it clear. So void, I need to provide the body, void integer a, some number. Then I'm going to say a number plus plus. If you don't know what this increment operator is, go read the chapter. So this method receives a value and it increments its value by 1. I'm gonna declare in main a local variable called num. I'm gonna say it's equal to 10. Then I'm gonna say increment, and then I'm gonna send num. After increment, I'm gonna display num. Now I will execute. Notice num started as value 10, then incremented num. When I displayed num, it's still 10. Why? This happened because lnum was passed by value to the function. Passed by value means there is going to be a copy of this variable that gets created and then sent to the function. Whatever the function does to that copy, it will not reflect the original copy. It will not reflect the original value. Whatever the function does to this variable, the original value will stay as is. And this demonstrated it. I passed it, and then it's still 10. This is passed by value. Now, the other approach is passing by reference. Passing by reference means whatever the function does to that variable, it will reflect or it will change the original value of that variable. And in syntax, in code, to differentiate between passing by value and passing by reference, I need to provide the ampersand character. This makes the function receiving an input by reference. Notice it's going to say function definition is not found. That's because this is one function, this is another function. This function called increment and takes a reference of an integer. This function is called increment and takes a value integer. These two are the same. In order to make them, these are not the same. In order to make them the same, I need to provide the body for this prototype. So now they are the same. Now, with this change, this will receive the integer as a reference. So whatever the function does to that variable, it will reflect the original, the original value. So I will execute. Notice now it's 11. Num was passed by reference, means it's the original copy. The function may is giving the original variable to that increment function. Whatever increment does to that variable, main will know about the change. So now displaying num will show 11 because increment modified that variable. By now, you know the return statement. Return in main is the last thing that gets executed. In other words, whenever this statement is called or this statement executed, the entire function will terminate. I can have the return at this level. Now, notice when I start my program, I declare variable return. Notice when I execute this statement, this is the end of the function. The rest will be ignored. The program will not do anything. So the return statement is terminating the function and returning a value to the calling function. Whoever called my function will receive the control back to it. Okay. Next is return types. Return types, as you saw here, a function can return nothing, void, or it can return integer, boolean, double, float, any data type, whether it's declared or created by the programmer or primitive. Primitive means provided by the language. Primitive data types are integers, float, double. And you have data types that can be created by the programmer, which we are going to see. Some of you already seen when you create a class, you are creating your own data type. When you create a struct, you are creating your own data type. So the return types are any of those, whether it's a primitive or abstract created by the developer. Local versus global variables. Let's make space. This here is local variable, meaning outside this scope, there is no access to that num. So if I go to a different function and I say cout al num, the program will not know about al num. Al num is not defined in this scope. Al num is local to main. It's not global, it's local. And this is where the standard of my naming, variable naming, comes from. I always prefix a variable with important indication. L for me indicates that this is a local variable. A for me indicates that this is an argument. So later, when my program is huge and my function is huge, and I look at this statement, instead of wondering, oh, what is a num if I have it as num, instead of wondering what is num, is it a locally declared variable? Is it a global variable? Did it come as an input? Instead of wondering and looking up where did this variable come from, by the variable name, I can tell that this is an argument num. By the variable name, I can tell that this is local. Now, this is for the variable naming. In this case, lnum is local to main. That means nobody else has access to it. Now, if I have a scope inside main, meaning something like a for loop or a while loop or an if statement or even an empty scope. Now, these children scope, they do have access to lnum. So lnum was declared at this level. This is a child scope, child scope, child scope. So lnum is accessible, but it's not accessible outside the scope. It's accessible to the inner scopes, yes, but not outside this scope. So it's like a tree. It's like a tree, right? If something is declared at this level, so everything below it has access to this, but nothing above it has access to it. This will have access to it. This will have access to it. This will have access to it. Now, global variables. In this case, global variables are similar concept. They are accessible within this scope. So if I say genome, now I can access genome at this level and any children scope below this at this level or below that levels. So if I include this file somewhere else, the somewhere else will have access to this variable because they are at the same level. Or any children levels. Main is below this level. Is a child scope to this level. Also, increment. Increment and main are on the same level, and both of them are below this level. So here I have access to genome. Notice? So if I have a genome at this level, and I also have a genome at this level, and then I call a cout at this level, for example, this is 1, this is 20. This will display the local one. This will display the 20. So the compiler or the program or Visual Studio will go and say, hey, do I have a genome at this level? If yes, then use the one at this level. If no, then use the one at the, or look up. Look up if I have a genome above this level. If I have above this level, use it. If I don't have genome above this level and I can't find it, then throw an error. I can't find it. So this is what you need to know between local versus global variables. Then you need to know about static variables. Static variables are variables that stay alive per se, if you want to say. So in this function, I'm going to say increment, do the task, increment A9, and I'm going to have an int L calls count equals 0. Now, calls count means how many times this function got called. I'm going to say every time someone calls me, I want to increment calls count. It starts with 0, and then I will increment it. So now I'm going to cout anum, and I will also cout L calls count. So here I have this global variable for now. Let's say I'm going to say increment g num. This increment will display at the same time. So I will do it like 5 times. So let's run. Notice that function increment takes it by reference. So this will increment it, will become 11. Then here it will become 12, 13, 14, 15. If it was by copy, then all of them will make it 11. And genome will, well, since it's global, let's change that. Let's say int l num equals 10. Okay. So this will receive it. If it's by copy, then all of them will make it 11, but lnum at this level will stay 10. Since it's by reference, the first will increment and then the second will know about the increment. So let me remove this output. Let's take this down, all of them down. So go. I will execute it 5 times. Notice 11 and calls count 1. 12 still 1. 13 still 1. 14 still 1. 15 still 1. What is the difference between num and count? Num is coming from outside the function. On the other hand, count is being declared local to this function. Any variable that is declared local, by the end of the function, this variable is destroyed, is gone, lost. So every time we're calling this function, we're creating a new variable, setting it to 0, and then incrementing it to 1. So it becomes 1. The next call, we're creating a new one, setting it to 0, incrementing to 1, and so on, so forth. Now notice when I add static. Static means the variable is not gonna die, will stay alive even if the function is done executing. So now what I will do is I will add the static and execute. Now notice 1, and then on the next call, the variable didn't die. So it was 1 from before, and it got incremented 2, 3, 4, 5. So the variable, because it's declared as static, it did not die by the time the function finished executing. This is for static variables. Now for default arguments. For default arguments, here I'm passing a variable. I can tell my program, hey, you see this input? In case you don't receive this input, I need you to use this value as default. So let's make it by copy because it doesn't work as reference. So I'm telling it in case, here is the default argument. I'm telling it in case somebody or some function calls increment and does not give you a value, I need you to use the value 20. So now notice, if I call increment and I don't give it an input, it's not an error. Earlier, it was an error. If a function is expecting a variable or a value and I don't send it, then it will error. But in this case, it did not error because it knows that if someone doesn't send me this, then I'm not gonna worry, and I will use whatever the programmer designed. So now notice when I execute, I might have to put it here in the prototype. And yeah, why not? Run. Oh, strange. I want to know why. Okay, go. So notice, because I didn't send a value, it used the value 20, which is the default. But I'm curious why it didn't work. Oh, integer. Let's go give it a num. Let's give it a name. We must give it a name here. And now it can work with a reference. No? Okay, without having it as a reference. So now run redefinition of default argument. Argument one. Now the fact that I put it in the prototype, I might not need it here. Let's see. Okay, so this is the way I give that. If in case you're having prototypes versus definitions instead of just definitions right away, you have to do the default prototype at a default argument at the prototype level. So what if I have two numbers, a num2? I can also do something like this. So I'm gonna display, for example, the sum of them. So I'm gonna say, let's get rid of these. A num equals a num plus a num2. So here in a num2, and I will only send, for example, let's say this is 30. So I will send only one. The fact that I'm sending only one, then this will be used for the first one. And then the second one, the fact that it's missing the second one, then it will use the 30 for the second one. So notice it will use 10 plus 30 and it will display 40. So I can send another one. I don't have actually to declare it. I can just say 10, 15. So I'm calling this function and passing 2. Here it is, 25. I can not default this one. That means if I don't send anything, now it's an error. It's gonna say, hey, I'm expecting at least one. I'm expecting at least one variable. However, if I default the first one but not the last one, it will not like it. Anytime you need to use a default argument, the defaulted variables should go at the end. So the defaulted variable should come here, and then the not defaulted argument should come at the beginning. So the way I had it will work, meaning the not defaulted at the beginning and everything defaulted at the end. And this is pretty much it for default arguments. Now for overloading functions. Overloading functions means you can have, let's make it simpler. Function overloading means you can have two or more functions with the same name as long as the list of parameters is different. Meaning I can't have two functions with the same type of parameters. It will not like it. For example, let's do another one. And let's say this time this anum plus equals 10 in this case. So now when I call increment, and I'm going to say increment 20, it should not work because I'm confusing the compiler. I have two increments, both of them take one integer, one increments by 1 and one increments by 10. So it's going to say, hey, I'm confused. It already has a body. Here, 2. Hey, I already have a body. So function overloading means you can have two functions with the same name as long as these are different. So for example, I'm going to say this one is double, this one is an int. So in case it's a double, I need to increment by 1. In case it's an integer, I need to increment by 10. So now, if I'm passing an integer, it's one thing. And if I'm passing a double, then it's another thing. Notice, now I'm passing integer, so the integer version will get executed and it will increment by 10. If I'm passing a double, then the double version of this function will get executed. That's function overloading. Function overloading is having two functions with the same name but different parameters list. The parameters can be one or more. It doesn't have to be only one. I can have three integers, three doubles, one integer, two doubles, two integers, one double, two doubles, one integer, etc. So as long as the list is different, then I can have them with the same name. It doesn't care about the return type. Return type can be anything. As long as the list is different, then you are allowed to do so. And this is it for reviewing chapter 6. Let me know if you have any questions, and if any of these topics is new for you, you must go and read the chapter. So this is chapter 6.